Welcome to another screencast where we'll be addressing cardiac output. So this is some basic cardiac physiology. So by the end of this, you should be able to identify and define really what cardiac output is. What do we mean by heart rate? And then also stroke volume. What is that? Discuss briefly here Starling's law of the heart, which is related, of course, to venous return. And then ultimately, what we'd like you to be able to do, this is the big deal here, and this would be like what a time writing would be on, is to be able to identify, describe, and explain here factors that affect the cardiac output. So again, describing and explaining here how cardiac output can be altered and how it's regulated, and then the effect of each of these on the heart rate and on cardiac output. Okay, so this is autonomic nervous stimulation, that is parasympathetic and sympathetic nervous systems, exercise, physical and environmental factors, as well as then hormones and ions, how they're going to affect the cardiac output. So let's get started. Everything you need to know is basically on this slide and on another slide from another text, but let's start here at the top. So cardiac output is defined as the volume of blood that's leaving the heart per minute. So the volume is in milliliters here, and then of course time is in minutes. So this is how much blood is going into the aorta here and into the pulmonary arteries, or the pulmonary trunk located right there. It's really the aorta that we're most concerned with, of course, because this is delivering oxygenated blood to the entire rest of the body coming out of that left ventricle. So really we focus here primarily on the aorta and how much blood is going into it, but knowing, of course, that the volume that's going into the pulmonary trunk is also the same. So the cardiac output then is a function of two things. It's a function, one, of the heart rate, and two, of stroke volume. So let's talk about each of those here independently. So the heart rate is defined as just the beats per minute. So how many times do you undergo diastole, systole in a minute, and specifically here ventricular systole. All right, so that is a beat. So if the heart rate is beats per minute, how many times that contracts, that is the heart rate. Stroke volume, on the other hand, the stroke volume, abbreviated SV, is the volume that leaves each ventricle in milliliters per beat. Right? So this is beats per minute, and then stroke volume is milliliters per beat. So how much comes out with each contraction, each ventricular systole into this aorta. Now, to get a little more technical, this stroke volume can also be defined as the end diastolic volume minus the end systolic volume. So this end diastolic volume is how much blood is in the ventricle at the end of diastole. So remember that diastole, that ventricle is going to be as full as possible with blood, right? And then at the end of systole, that ventricle is going to be has squeezed out, hopefully, most of its blood. So the difference between how much blood was filled up here and how much gets squeezed out, or how much is left at the end of systole, not all that blood gets squeezed out in systole. This is the stroke volume. So to put some numbers on that real quick, if the end diastolic volume was 140 milliliters, and the end systolic volume is 70 milliliters. Right? So not all the blood gets squeezed out in systole. The stroke volume then would be 70 milliliters. So if that's happening every time the heart undergoes systole, right, every beat, and if the heart is beating at 75, right, which is somewhere between 60 and 100, right? So this is kind of the heart just sort of at rest, or like normal situation here. The cardiac output could be then calculated by taking, so if cardiac output is equal to the heart rate multiplied by the stroke volume. So if it's heart rate, this is 75 beats per minute, right? And then multiplied by the stroke volume, which we said over there it was 70 milliliters per beat. Right? You notice that the beats cancel here, and you're left with 5,250 milliliters per minute. So this 5,250 milliliters per minute is about the entire volume of blood that's in your body. Okay, so every minute you just sitting here listening to this, your heart rate is somewhere in this range, of course, right? And so it's probably, we'll just pick 75. And every minute that you're listening to this, your body is pumping that much blood through the entire systemic circuit. Okay, pretty interesting. Now, this is important because, of course, the blood is delivering oxygen to the tissues, and it's bringing carbon dioxide away from the tissues. And this needs to happen constantly as long as you want to continue living. So the cardiac output is an important thing to know here, but there are two factors, of course, that define that cardiac output, right? Heart rate and the stroke volume. Now, you are never really just sort of at rest. There's always something sort of happening to you. So everything kind of outside of this area right here, everything, oops, on the outside of that line are going to be factors that can affect cardiac output. Right? So I put a box around all the cardiac output definition and description and stuff there. So everything outside of that box will affect that cardiac output, either by affecting the heart rate and or by affecting the stroke volume. Right? For example, if we come down here, if you have low blood pressure, right, and that is meaning that you are hypotensive. Tension, pressure, hypo is below, so low pressure here. If you have low blood pressure, that low blood pressure is going to be detected by special cells that are in the aorta here, right? That are baroreceptors, stretch receptors. And so those stretch receptors will detect that low blood pressure. When those baroreceptors detect that low blood pressure, that stimulates, and that's what this green arrow is right here. So baroreceptors detect that. That stimulates the sympathetic nervous system here to begin to then fire action potentials, right? So here we have action potentials that are going to go directly via sympathetic fibers to the SA node, AV node, and Purkinje fibers here. So these things get stimulated directly by the sympathetic nervous system, and that is going to cause those to depolarize faster to threshold, and therefore the myocardium of the atria will contract faster. The myocardium of the ventricles will then also begin to contract faster. And so this heart rate value is going to go up, and if this factor goes up, then when you multiply that out, your cardiac output is going to go up. Well, when the cardiac output goes up, that means that more blood, because the heart is beating faster, more blood is going to then be entering this aorta, and because the heart's beating faster. And when more blood enters that aorta, the blood pressure is then going to come back up, and you will no longer be hypotensive. Interesting thing here, this low blood pressure will stimulate this sympathetic nervous system, and that sympathetic nervous system also will affect the stroke volume. So what happens with the sympathetic nervous system, it signals the myocardium to depolarize faster over here, but over here it increases the contractile force of the cardiac muscles. So the myocardium beats stronger, right, with more force. So with more force, right, stronger beating means that each time you contract, the volume of blood that's going to leave that heart is also increased. So the hypotension has will stimulate both the increased stroke volume and an increased heart rate, which leads to greater cardiac output, which is then going to serve to then reverse this hypotensive situation. Okay. One final thing over here about the stroke volume. You read about the Starling's law of the heart, and Starling's law of the heart says that the volume that comes back to the heart will be then pumped out. So how much blood comes back to the heart will then be pumped out. So when we're talking about venous return, right, over here, so let's just briefly talk about venous return. So here's venous return, and venous return is how much blood is returning to the heart. And when I say how much, I mean a volume, okay? Returning to the heart in veins, right? So this word venous here, venous is an adjective, right? So how much blood is coming back to the heart in the veins, and that's a definition of a vein. So the more blood that comes back to the heart, the end diastolic volume will then be larger because you're able to put more blood into those ventricles, right? So increased venous return increases end diastolic volume, right? And decreased venous return lowers end diastolic volume, okay? So one final thing about that, Starling's law of the heart and this venous return, is that if my increased end diastolic volume goes up, this stretches the ventricles even more. And those stretched ventricles will then be signaled to contract with even more force. So stretched ventricles contract with more force. So that is then going to, of course, increase the amount of blood, the volume of blood that leaves there. That increases the stroke volume as well. Okay? So that was a lot. And what I'll ask you to do is kind of maybe re-look at that, rethink about that, summarize that. Here is another image that has all that same information, just presented it graphically a little bit different, so you can work your way through this. Here's the color coding down here to take a look at, and this is an opportunity for you to practice. So I would say look at this one and say, all right, what is that going to do? Right? Here's the cardiac output at the bottom, so maybe take that back. So start here at the bottom, right? Cardiac output is a function of the stroke volume and then the heart rate, right? So this is an opportunity to sort of practice and work your way through. Finally, here is another, what I might ask you to write about, sort of timed writing, right? So for each of the following stimuli, I'd ask you just to pick one of these, right? Hemorrhaging, exercise, emotional stress, or hypertension, to predict the effect on the cardiac output. Right? And then this is really where the meat of this is to describe and explain the physiological mechanisms, that's the pathways that produce those effects. So things I'd be looking for in the timed writing are here, considering which factor of the cardiac output is being affected, right? The heart rate and or the stroke volume, and then a little description about how. Looking for you to demonstrate the correct anatomical and physiological terminology, be able to demonstrate the correct use and understanding of previous knowledge of other systems and organs. So for example, looking at sympathetic nervous system, right, and action potentials and understanding the depolarization and everything like that. So bring that into your answer. And then finally, to demonstrate an understanding of homeostasis. So I've given you an example. I told you the example in the screencast, and here's the example sort of written out down here, where I chose hypotension as my example. And then this is what my timed writing answer kind of would sound like. Right? So please read through that and then sort of pick each of these and try to write an answer that sounds like this, right? Or that reads like my example there. Okay? So you should now be able to identify and describe here what we mean by cardiac output. There's an actual definition for that. What we mean by heart rate and stroke volume. Talk a little bit about Starling's law of the heart and as it relates to venous return. And then some factors that affect the cardiac output. And then with the timed writing, hopefully you'll be able to do these things down here, describe and explain the effect of each of those things on the cardiac output. Okay? Thanks for listening. Bring your questions to class.